When we hear nerve-wracking reports about asteroids, it almost seems as if galactic death is lurking around every corner. How devastating the consequences for life on our planet would be if our earthly home were actually hit by a gigantic asteroid can be illustrated particularly well if we turn our gaze 66 million years into the past. The asteroid, 2021 GW4, the Mount Lemmon Survey is located on the summit of Mount Lemmon in the US state of Arizona. The highly complex technical equipment, which belongs to the Mount Lemmon Observatory and is part of the superordinate project Catalina Sky Survey, pursues exactly the same purpose as all other Cassegrain telescopes, to search the starry sky for galactic formations that could theoretically become dangerous for our Earth. And indeed, on April 8th of this year, the Mount Lemmon Survey located a relatively small, yet exceptionally fast celestial body that was approaching our blue home planet within range of concern. Fortunately, the asteroid, which was baptized 2021 GW4, was supposed to pass our Earth without causing any damage. The unrestrained power inherent in the approximately 15-foot-long galactic rock becomes apparent if we take a look at the rapid speed with which 2021 GW4 sweeps through the infinite widths of the universe. In fact, the speed of the asteroid is an incredible 18,000 miles per hour. The object finally flew past our terrestrial home on April 12th, with the asteroid approaching Earth at times within about 12,000 miles. For comparison, the distance between the Earth and the Moon is almost 240,000 miles, many times this distance. Although this small distance between our planet and the asteroid seems extremely threatening at first, experts assured that the flyby of the stony projectile was a harmless event. In spite of how short this distance was in the galactic context, it was not possible for us to see the darting object in the sky with the naked eye. It was simply too small for that. In any case, the danger from an object of this order of magnitude seems... The Chelyabinsk Meteoroid. At the time, the people of this city of over 1 million inhabitants in the Urals spotted a strange, fast-moving object in the sky. It quickly became clear that this was a meteor. When the galactic rock finally entered the Earth's atmosphere, it exploded a good 18 miles above the surface with a tremendous force that terrified the inhabitants of Chelyabinsk and the surrounding settlements. In fact, the force of the detonation was so strong that it was roughly equivalent to the explosive power of 500 kilotons of TNT. The immense shockwave that spread over the Earth ultimately caused thousands of window panes to shatter. According to official estimates, between 3,700 and 7,000 buildings were damaged, and nearly 1,500 people were injured. Most of these injuries were cuts caused by flying glass fragments. The meteoroid in question was the largest celestial body to strike Earth in the last 100 years. The formation measured about 60 feet in length and had an impressive dead weight of 10,000 tons. More than 3/4 of the object were destroyed in the course of the explosion. The largest partial fragment, a chunk of rock weighing more than 1,100 pounds, probably fell into Lake Chabakul. 2020 QG. A look at statistics shows how close we have come to colliding with an asteroid in the past. In 2018 alone, 91 galactic projectiles passed the Earth at a distance of less than 240,000 miles. As already mentioned, this is the distance that lies between our home planet and the Moon. This distance serves as an important benchmark for experts in determining potentially dangerous asteroids. However, the fact that this orientation distance is often significantly undercut was demonstrated once again on August 16, 2020, when asteroid 2020 QG flew past Earth at a distance of just 1,800 miles. No other officially recorded asteroid has ever come as close to our planet as 2020 QG, whose diameter is estimated at about 18 feet. The devastating consequences of an asteroid impact. In view of these numerous asteroid flybys, the question arises whether any object is known that may actually threaten to crash into Earth with unbridled force at some point. Fortunately, experts can give the all-clear regarding this concern. At present, there is no potentially dangerous celestial body on the radar of scientists that could pose a real threat to us in the foreseeable future. In April 2020, the asteroid 1998-2 hurtled past our earthly home at a speed of 36,000 miles per hour. To give you an idea of how fast this abstract-sounding speed is in reality, an average rifle cartridge travels at a speed of 2,013 miles per hour from the barrel of the gun. If 1998-2 had not passed by us last year at a generous distance corresponding to about 16 times the distance between the Earth and the Moon, but had actually hit the Earth, the consequences for the planet and its inhabitants would have been simply catastrophic. The impact of the estimated 2.5-mile-long projectile alone would have caused an enormous crater, which would have reached more than a half-mile into the Earth. A large city the size of Berlin would have been completely wiped out in a few moments as a result of the collision and the associated shock wave. But even more devastating than the direct destructive consequences of the asteroid impact would be the effects that such an impact would have on the climate of our planet. The dust and ash raised by the impact would throw the climate of our planet into sheer chaos. The consequence? Severe agricultural crises and great famines. How can we prevent an asteroid collision with Earth? What can we do if our home planet is really threatened by an apocalyptic scenario? In such a case, can we only silently hope that the falling celestial body will cause as little damage to Earth as possible? Or are there measures that can be actively taken to prevent a devastating collision? The answer is theoretically yes. However, such an asteroid defense maneuver has not yet been carried out in practice. The greatest hopes that experts have for asteroid defense are currently pinned on the Asteroid Impact and Deflection Assessment Project. This is a joint mission of NASA and ESA in which an unmanned spacecraft is to be directed at the double asteroid Didymos. For the first time, scientists will attempt to manipulate the trajectory of a galactic body. NASA's DART spacecraft, which will be launched at Didymos, is expected to leave our planet this fall. About 3 years after that, the Hera spacecraft is expected to head to the site of the collision and provide important information about the orbital changes of the double asteroid. Ingenious asteroid defense methods. Another no less ingenious asteroid defense variant provides that the deadly structure be flown around by an unmanned space probe at a short distance. The idea behind this is that the circular movements of the spacecraft would lead to the asteroid being coupled to a kind of invisible galactic tow rope due to the force of gravity acting on it. If this highly sophisticated endeavor actually succeeded, the effect of gravity could slowly but steadily move the perilous asteroid out of its established orbit. In addition, a process is under consideration in which the side of the asteroid facing the Sun would be sprayed with white paint. The white layer of paint would reflect the sunlight much more strongly, causing a small counterforce to act on the rocky lump, which could also steer the object onto a different trajectory. For this to succeed, however, the dangerous asteroid would have to be discovered early enough, as it would take many years to throw the structure completely off its natural course. And precisely this circumstance is a major problem of terrestrial asteroid defense. Some galactic projectiles are discovered only at the last minute. For example, in July 2019, an asteroid the size of a soccer field passed Earth, which experts had noticed only a few hours prior. If the objects are in an unfavorable spatial constellation and are practically flying straight toward our home planet, it's extremely difficult for experts to locate and interpret the asteroid's movements amid the countless other celestial bodies. We hope you feel informed and inspired by our contribution today. Feel free to share your feedback in the comments. Thanks for watching. We'll see you next time.